So my name is Jim Polito. I've been at LSC North Harris as a full-time math instructor. This is the finish of my 36th year. Oh my gosh. And so I will be finishing up 36 years this semester. And so I've been doing this a long time. And so I've taught all the classes, like intermediate algebra, dozens and dozens and dozens of times. But I've also taught the classes before this one and the courses after this one. And so the good thing for that, I think, is that I know what I'm doing, I guess is basically the way to say it. And so I know what you should be coming into this class with, what material you should already be familiar with, and I definitely know what you should be leaving this class with. And that's going to be my primary goal. My primary goal all semester, and you'll hear me talk about this frequently during the semester, is to prepare you for college algebra. Now, whether that's the class that you're actually going to be going into or not is, that may be different for those of you from different backgrounds. Some of you have different majors or different certificate programs, and so you have different goals in your academic career. But that's basically what I'm going to be looking at, is preparing you for Math 13-14. And if I do that, if I prepare you for Math 13-14 so that when you walk out of here and watch your last lecture and take your final exam in May, and that if you are ready for college algebra, then then I've achieved that goal, and then you're also ready for other classes that you might be taking besides college algebra that are math classes like statistics or the Math for Liberal Arts class or something like that. So, but I will frequently be referring to college algebra during the semester and talking about things that we're going to be dealing with this semester and that you need in college algebra. And so that's my overriding goal always throughout the semester, is to deal with preparing you for college algebra. All right. So this semester, what basically we will be doing is this semester we are going to start off kind of going through different kinds of algebraic expressions that you encounter in college algebra and making sure that you can work with them. Basically is one way to look at it. So we're going to start off with polynomials. And I'm going to briefly talk, and that's what we're going to actually start with today, but I'll briefly again go back over what a polynomial is and some basic stuff about polynomials. And we'll review operations, in other words, adding, subtracting, multiplying, and dividing polynomials. And then what we will spend our time with is factoring polynomials. Factoring is an important algebraic skill for various different situations. And so factoring polynomials is one thing that we will talk about for several days. Now, that is something that I expect that you've seen before. If you took Math 0308 in the Lone Star system, you talked about factoring polynomials in that class. And so for those of you who've done that recently, you'll find that it's kind of, in some ways, a review. We'll be going a little bit further with factoring polynomials than you would have seen in 0308 probably. And then we're also going to be talking about solving equations that have polynomials is in the equation. So we'll do some stuff with polynomials. That'll be our first algebraic expression. And then we're going to move on to talking about rational expressions. Now, a rational expression, you'll hear me use that phrase frequently through the semester. A rational expression, as far as the way you should think about it, you should just think about it whenever you hear those words, rational expression, think about a fraction. But not a fraction necessarily like 3/4 or 5/9 or something like that, but fractions with polynomials. So we will be looking at rational expressions quite a bit. And that is something that I don't really look at as a review topic. Now, I know some of you have covered rational expressions before in other classes, but I'm going to look upon that as something that you're going through kind of sort of for the first time, or it's been a while since you've done it. So you need a lot of reviewing with rational expressions. So that'll be our next algebraic expression to deal with. And then after that, we will look at radicals. And when I talk about radicals, remember we're talking about square roots, cube roots, things like that. There's several things that are important in algebra that you've got to be able to work with square roots and some with cube roots and be able to deal with those effectively in college algebra. So we'll talk about square roots, cube roots, all that kind of stuff. And then we'll also talk about exponents. Exponents are important. And those two topics in particular, radicals and exponents, always go together. And there's a reason why they go together, and we'll talk about what that reason is. What radicals and exponents have that ties them together. There's something that's very important that connects those two things, and we'll talk about that this semester. And then we'll be looking at exponents in terms of what you would need for exponents for a success in college algebra, especially when you're dealing with logarithms. Logarithms is a big topic in college algebra, and you have to be good at exponents in order to deal with logarithms. So we'll deal with that. So we'll go through polynomials, rational expressions, radical and exponent expressions, kind of go through all those different things. And then we will turn our attention for the last part of the class, and this is an important part also, we're going to look at equations. Now we'll look at equations throughout this other stuff with polynomials and rational expressions and radical expressions also, but we'll turn our attention to equations in particular in two variables. And so when I say equations in two variables, we're talking about graphing, and in particular graphing and functions. And so we'll spend quite a bit of time towards the end of the semester talking about graphing, different kinds of equations, going through some basic graphing, and also doing an introduction to functions and what a function is. Critical for success in college algebra. That's a big deal, and that's one reason why we kind of finished the semester with that topic, because it's a big deal in college algebra. All right, so that kind of lays out what we're going to do for the semester. And I know for a lot of you who are, both of those of you who are with me live and those of you who are going to watch this recorded video later, I know math. I understand that math is not maybe necessarily your favorite subject for a lot of you. Some of you like math. I understand that, are pretty good in math. It's just been a while since you've taken it possibly. But I also understand that a lot of you that this is not a class that you're overjoyed to be taking necessarily. And so a whole semester of algebra is not necessarily maybe one of your more pleasant thoughts. And so I understand that, and I will kind of keep that in mind as we go through the semester. But the way I look at it is I have some stuff that we've got to do to prepare you for the next class, and that's my take on it, is that, and that's my job, is to prepare you for what you're going to be doing next semester. And so I will be doing my job during the semester. And so, we'll kind of get hopefully familiar with each other as we go through the semester, and it'll be hopefully you'll find it to be an enjoyable experience. Believe it or not, as you go through the semester, I had a good group of people online with me in the fall semester, and we got pretty comfortable with each other, and so it was ended up being a good experience, I think, for those students especially who attended live. So, all right, so enough of all that stuff. What we're going to be doing is we want to get started and talk about polynomials and do some reviewing with polynomials, and so that's our first goal here, is to deal with polynomials and get you ready for factoring polynomials that will start on Thursday in Thursday's lecture. So first of all, what the heck is a polynomial? Let's make sure that you know what a polynomial is when you see one. This polynomial has these characteristics. First of all, it consists of several terms. Now, when I say several terms, there's a couple things there. First of all, the word several, that just means one or more for our purposes, one or more terms. And the word term simply means things that are being added or subtracted. All right, so a polynomial is an addition or subtraction problem. It's got a couple of things that are being added or subtracted. Obviously, if it's just one term, it's not. There's no addition or subtraction at all in that case. Let's see. We have somebody new online, so hopefully, let me. If you guys would just pause for just a second, make sure that. Our new person actually sets up their audio.
Professor?
Raina. Yes.
Can I hear you? Oh, there you go. It went off for a while.
It went off? Really?
Yeah.
Well, I stopped talking, so maybe that was it. I don't know, but I need to.
No, I saw your lips moving. So
But okay, we're back. Okay. I'm just typing in a chat to somebody who just logged on. For those of you who are with me live right now, what you'll notice is that if you go back and watch this recorded video, you won't see this stuff in the recorded video at all because I go through and edit this stuff out. The software I use allows me to edit it out pretty easily, so I'll go in and actually cut this stuff out. All right, so we're talking about polynomials. We know that a polynomial consists of several addition or subtraction problems. Each one of the things that you're adding and subtracting is called a term, and the terms always look like this. They're always constants times powers of variables. That's what a polynomial is. It's really not hard to think about it that way. And the constants are called coefficients, sometimes called the numerical coefficient. And the powers of the variables determine the degree of the polynomial. So these determine the degree of the polynomial. And these are things that a college algebra student will need to know about polynomials. So, all right, so when we're talking about a polynomial, we might be talking about something possibly like this. This would be something relatively simple, 3x squared plus 6x minus 8. It's got three terms, right? It's got three things that are being added or subtracted. So it has three terms. The three terms are 3x squared, 6x, and negative 8. Remember that the sign always goes with the term. All right, so the negative 8 would be the last term of that particular polynomial. Each term is what? Is a numerical coefficient times a power of a variable. So it's 3 times x squared plus 6x minus 8. Now to find the degree of each term, you simply add the exponents of all the variables. So I'm going to write that down right here. Put an arrow there that's how you determine the degree. So the degree of the first term is degree 2 because it's got an x squared in it. The degree of the second term, that's a 6 times x to the first power, and so that's degree 1. And then the last term, the 8, does not have a variable in it. Technically, that's 8 times x to the 0 power. We always say that a constant is degree 0 because that's 8 times x to the 0, technically. All right, so the degree of the polynomial is simply the biggest of those degrees of each of the terms. So the degree of the polynomial, in this case, is 2. because that's the biggest one of the degrees of each of the individual terms. All right, and hopefully most of you remember this, that a polynomial with 3 terms is called, in particular, a trinomial. A trinomial is really just a special name for a polynomial with 3 terms in it. That's all it means. All right, let's see. So if we have 5x cubed y to the 4th plus 8x to the 7th y minus 9z to the 4th w squared. Yuck. And let's put in one more term. Minus w to the 5th power, like that. Okay. So this is a polynomial with 4 terms in it. Right? There's 4 things being added or subtracted. And remember, the sign goes with the terms. So the terms are 5x cubed y to the 4th, 8x to the 7th y, negative 9z to the 4th w squared, and negative w to the 5th, like that. The degree of each of those terms, you add the exponents on the variables. So this is degree 7. The next one, be careful, that's x to the 7th and a y to the 1st. So this is degree 8. This is degree 6, 4 plus 2. And then the last term is degree 5. So the degree of the polynomial, what's the degree of the polynomial? For those of you who are listening right now, what's the degree of the polynomial there? Anybody want to shout out the answer? Remember, you pick the degree, the biggest degree of any of the terms. So what's the degree of the polynomial?
7.
Raina, what's the biggest one?
7.
Raina, what's the degree of the second term?
Oh, no, 8.
There you go. So what's the degree of the polynomial? The degree of the polynomial would be 8, right? And what you were making a mistake on, Raina, is you were looking at the first term, and it's not always necessarily the first term that determines the degree of the polynomial. It's the biggest one. And it doesn't matter where the biggest one is. Sometimes it's the first term. Most of the time it's the first term. That's how you try to write it, but it doesn't have to be. And so in this case, the second term was the biggest degree. And so that's the degree of the polynomial, is degree 8. All right. Okay, so, and by the way, so I'm going to keep you guys on your toes. So occasionally I will ask you questions and try to put you on the spot and get you to answer some questions, because I want this to be not a video that you're watching. I would much rather this be treated as kind of like a class that you're sitting in on. And so just like any math class, or hopefully any class, that, you feel free to stop me, say, hey, I don't know what the heck you're talking about, or please answer questions if I'm asking a question of the class and everything. Don't hesitate to shout out the answer. All right, so that's a little bit about just some introductory stuff about polynomials, some very introductory stuff. So what we want to do in particular today is go through and review operations on polynomials. And not all the operations at this point, but what we want to do is talk in particular, when I say operation, we're talking about add, subtract, and multiply. We're not going to talk about division at this point. We don't need division for right now, and so we will worry about that some other time. So right now we want to talk about add, subtract, multiply polynomials. Now, in order to be able to do that, I do need to kind of go back through some stuff about exponents, because that comes up as we go through this. And so first, let's work with exponents for a few minutes. All right, so and I'm going to go through and review some rules. So I'm going to write a rule down. I'm actually going to number them here. I certainly would never ask you, hey, what's rule 1 or what's rule 3 or whatever, or something like that. But what I will want you to be able to do is recognize when these rules apply. and kind of go from there. So rule one has to do with what happens when you take two of the same variable that are raised to powers and multiply them together. So you have x to the a times x to the b. And the rule is that x to the a times x to the b is x to the a plus b, right? When you multiply like bases like that, you add the exponents. So hopefully you remember that. And so as an example here, if we have x to the fourth times x to the sixth, that's x to the 10th, right? You add the exponents. But z to the seventh times z, which is just z to the first, you add the exponents, the z to the eighth. It doesn't make any difference if you have a constant raised to the power. So 3 to the fifth times 3 to the eighth is 3 to the 13th. Please make sure you note here, note that 3 to the fifth times 3 to the eighth is not 9 to the 13th. No. Right? You're not multiplying the threes together. You're multiplying powers of 3 together. And so you're saying you've got 5 threes and 8 threes. And so how many threes have you got? You've got 13 threes, right? You don't have 13 nines. You have 13 threes. And so make sure that you don't misapply that part of that rule like that. So be really careful about that. All right, so when you multiply like bases together, you add the exponents. Rule 2, if you take something that's raised to a power and then you raise that to a power again, so you have the x to the a raised to the b power, you multiply the exponents in that case. And I get students all the time getting these two confused, so you have to be really careful when you multiply exponents, when you add exponents. All right, so x to the a to the b power is x to the a times b. So I'm talking about something like this. If you have x to the fifth raised to the sixth power, that's when that rule applies, and you get x to the 30th when you have something raised to a power and then it's raised to a power again. Z to the 9th to the 2nd would be z to the 18th. 4 to the 5th squared, you're not squaring the 4, right? So you're squaring 4 to the 5th power. And so that is 4 to the 10th power. It is not, again, so note, let's see. Note, again, that 4 to the 5th squared is not 16 to the 10th power, right? You're not squaring that 4. I see students doing that all the time, right? That's a no right there. So I should put not equals in both of those cases. Make sure you know that those are just misapplications of rules like that. So be really careful about that. Okay, so that's rule 2. And rule 3. When you have a multiplication problem raised to a power, x times y to the a power, then you can raise each factor individually to the a power. So x times y to the a power is equal to x to the a times y to the a. Now, this is probably the single most misapplied rule that we have in algebra, by the way, believe it or not, and I'll show you why. So x times y to the 5th power is x to the 5th times y to the 5th, right? If you have a multiplication problem, exponent rules apply. So, and that's probably something to write down off to the side here, is that exponent rules apply to multiplication problems. Right? You can, if you have a multiplication problem, you can use an exponent rule. So x times y to the 5th power is x to the 5th times y to the 5th. 3ab to the 4th power. There are now 3 factors inside the parentheses. And so you raise each one of those separately to the fourth power, right? The 3 is a factor just like the A and the B. Don't leave it as 3 to the fourth. If it's reasonable, go ahead and multiply it out. So 3 to the fourth is 3 times 3 times 3 times 3, which is 81. And so you can raise each factor separately to that power, like that. And so now you can, some of the other rules come into play also. So if you have negative 2x cubed y to the fourth, and this is squared like that, well, it's a multiplication problem inside the parentheses, isn't it? That's all multiplication. So the rule of exponents applies, right? Exponent rules apply to multiplication problems. And so that means you can raise each one of these factors to the second power. Notice I am using parentheses when I do that. You always use parentheses when you write it out like that. So be careful. The first one, negative 2 to the second power, that's 4. That's positive 4 because it's negative 2 times negative 2. And then one of the other rules of exponents applies to these next two pieces because you'd have x to the 6th. You multiply exponents there, and y to the 8th because you multiply exponents there. All right, so exponent rules apply to multiplication problems. That's rule 3. Rule 4, and then I'm going to show you how Rule 3 and 4 are misapplied in a second. Rule 4 has to do with division problems, right? So it's x over y to the a power. And the rule of exponents applies here, that you just raise the numerator and the denominator separately to the a power there. So off to the side here, we can say that exponent rules apply to division problems. Right, so if you have, if you have 4x over y to the 5th, and that is cubed like that, then that rule of exponents applies. And so you have 4x to the 3rd over y to the 5th to the 3rd, right? You have a division problem. So this rule of exponents applies here. And then you have more rules involved here, right? The numerator is a multiplication problem. So you have 4 to the 3rd, x to the 3rd. In the denominator, you multiply the exponents and you get y to the 15th. And so you end up with 64x to the 3rd over y to the 15th when you multiply all that out. Now, you won't encounter anything quite that messy at this point of the semester. When we deal with polynomials, you're going to just deal with more basic ideas with exponents, but I do want to kind of show you some examples as we're going through this. So what does Rule 3 say? Rule 3 says that exponent rules apply to multiplication problems. Rule 4 says exponent rules apply to division problems. Rule 5, the misapplication here is that, okay, rules of exponents apply to multiplication problems and division problems, but rules of exponents do not apply to addition or subtraction problems. So if you have an addition or a subtraction problem, don't you dare try to use a rule of exponents to simplify that. So how does that work? Well, x cubed plus x squared, for example. Right? That's an addition problem. Rules of exponents do not apply there. I cannot simplify that. I cannot add these together. Cannot add. It's just not anything you can do. Now, you could do some factoring there, but you can't do any adding here. And so rules of exponents don't apply in a problem like that. If you have y to the 9th minus y to the 3rd, I cannot subtract. Right? It's a subtraction problem. Rules of exponents do not apply in that case. So you can't, there's nothing you can do to combine those. And then in another place that I see this frequently misapplied is when you have a problem like this. So if you have, for example, a plus b squared, right? You're squaring an addition problem. Rules of exponents do not apply here, and so this is not equal to a squared plus b squared, right? You can't, compare that to a times b to the second power, which is a squared times b squared, right? It does apply to multiplication. It does apply to division. It does not apply to addition. It does not apply to subtraction. So a minus b squared is not equal to a squared minus b squared. Probably the single most biggest misapplication, most common misapplication I see is that example right there where you're squaring something like a plus b or a minus b, right? Those are addition and subtraction problems. You're not allowed to square each term like that. Rules of exponents do not apply to addition or subtraction problems. So you have to be careful there. All right, let's see. So we've gone through 4 rules. The next rule I want to look at here, so this is rule 5, I guess. We have x to the a over x to the b. When you divide common bases like this, you subtract exponents. And so you have x to the a minus b. Now, that actually leads us into a couple of other things, and in some cases we don't really want to talk about it too much at this point. But so, for example, if you have x to the 9th over x to the 3rd, that would be x to the 6th, right? You subtract exponents. Y to the 10th over y, you subtract exponents. That's 10 minus 1, and so that'd be y to the 9th, like that. Now, what that does bring up when you subtract like that, it does bring up the possibility that you could get 0 as an exponent, and that's actually rule 6, that x to the 0 power, as long as x is not equal to 0, x to the 0 power is equal to 1. And the reason why is because of rule 5 right there that we just did. You know, if you have x to the 5th over x to the 5th, that's x to the 5 minus 5, or x to the 0. But what do we know x to the 5th over x to the 5th is? What happens when you divide a number by itself? Well, you get 1. And so the only way that that could be true is if x to the 0 and 1 are actually the same thing. So as long as you're not, if the number's not 0, then you take something and raise it to the 0 power, you get 1. 0 to the 0 power, by the way, is meaningless. So 0 to the 0 is a meaningless expression, right? And so we never look at 0 to the 0 power. But anything else to the 0 power besides 0 is going to be equal to 1. So 3,897,653 to the 0 power, sure enough, it's equal to 1. All right, it doesn't matter how big the number is or anything like that. Now, the other thing that subtraction rule brings up is negative exponents. That is not something we want to deal with at this point of the semester. So I'm not going to worry about this. This is what I'm talking about. So like if you have, so this is rule 7, but if you had x to the 5th divided by x to the 7th, technically the rule would be x to the 5 minus 7, because you subtract exponents, but that gives you x to the negative 2. And so the question is, what is x to the negative 2 equal to? Now, I'm kind of assuming that you've encountered that before in an algebra class, but we are not going to talk about negative exponents now. So we're going to talk about negative exponents later in the semester. So we're going to finish rule 7 later in the semester, and then there's a rule 8 and 9 that go along with this that we need to talk about later in the semester. So we'll talk about later is what I'm going to say here. We are not going to deal with negative exponents. When you deal with polynomials, you're not dealing with negative exponents typically. So, all right. So now to finish what we want to talk about today in class, we are going to look at adding and subtracting and multiplying polynomials. So we've done a really fast review of some basic exponent problems. And so now we're going to look at adding and so adding polynomials. And we're going to look at adding, subtracting, multiplying, dividing. So adding polynomials simply involves adding like terms together. And like terms, remember, are terms with the exact same exponents. And so 8x squared plus 9x squared, those are like terms. You're not using rules of exponents here. All you're doing is adding two terms together, and you're getting 17x squared. 3ab squared minus 5ab squared, those are like terms. They have exactly the same variables. And so you can subtract those and get negative 2ab squared. 4x squared y minus 8xy squared, those are not like terms, and so you can't subtract. And you can't use the rule of exponents either. So you can't subtract there. So you need that little tidbit talking about like terms there to be able to deal with adding or subtracting polynomials. Okay, so to add polynomials, so as an example here, we have 3x squared plus 9x minus 6 plus 8x squared minus 11x plus 15. I'm definitely assuming that this is something that's easy for you, that you have encountered something like this before, right? This is an addition problem, right? This is adding, and all you're doing to add two polynomials together is you're simply just collecting like terms. In this case, the parentheses are not necessary, and so you could rewrite this problem without the parenthesis, and then you're simply going through and finding the like terms and adding them together. Right, so you've got 3x squared plus 8x squared. Those, I'm just rearranging the terms so that the like terms are next to each other. Plus 9x minus 11x, and then minus 6 plus 15. Right, and notice what I did is I rearranged the terms, and the like terms are sitting there next to each other. Most of you, when you do a problem like this, probably would never write it out that way. You would just collect the like terms and never actually do the rearranging. But that's really what you're doing. So you have 11x squared minus 2x plus 9 when you collect all the like terms there. And so we've added those two trinomials together. Pretty simple. That's adding polynomials. And I'm not going to go any further than that, because that's really all we need when we're dealing with factoring polynomials, is you need to be able to do something like I just did right there. So that should be pretty straightforward. Subtracting polynomials. Pretty much the same thing as adding, except you just need to be careful with the signs. So as an example, if we have 5x cubed minus 9x plus 15 minus 3x squared minus 11x plus 6, something like that. The only thing you have to be careful about is when you're subtracting these, it's kind of like you're treating the subtraction as a negative sign sitting out in front. And so you're distributing this minus sign through. It's really the distributive property, and you're really just multiplying through by a negative 1 right there. And so when I rewrite this without parentheses, what happens to the signs of that second polynomial? Well, they all change, right? Because you're multiplying all of them by negative 1. So you have negative 3x squared plus 11x minus 6, like that. And then you go through and collect like terms. Now, there are some terms in here that aren't like with anything else. So, right, the 5x cubed just comes down like it is, because there's no other cube terms in the polynomial. And the minus 3x squared comes down like it is, because there's no other squared terms in the polynomial. But I do have two x terms. I have a negative 9x and a positive 11x. So I add those two together, and I get plus 2x. And then finally, the 15 and the negative 6 are like terms, and I add those together, and I get 9. And so when I've subtracted those two polynomials, that's what I get right there. 5x cubed minus 3x squared plus 2x plus 9. And so we've subtracted those two polynomials. And again, I really don't need you to be able to do much beyond that when you're talking about factoring polynomials. So that's all we're going to look at right there. And again, that's something you should have seen before. You should have subtracted polynomials somewhere in an algebra class before. And this is just bringing back old fond memories, and you're saying to yourself, hey, I can do this. This should not be too much of a problem. Multiplying polynomials. Okay, so let's a little bit more to deal with there. And this is the last thing we're going to talk about today. Multiplying polynomials. All right, so with multiplying polynomials, first of all, there's a lot of different situations that could come up. That's what we need to talk about that a little bit. So if I have 3x squared times, let's say 4x cubed minus 8x squared plus 9x minus 11, something like that. When you have a single monomial term, that's just, a monomial is a polynomial with just one term in it. So I've got that 3x squared sitting out in front. And it's multiplied by a polynomial with several terms. This is a distributive property problem. And so you use the distributive property when you think about a problem like this. So what that means, remember, is that I'm just multiplying through by 3x squared by each one of these terms, like this. And draw arrows like this to show the multiplication. Right, so this is just the distributive property. And then notice this is where the rules of exponents that I reviewed at the beginning of the lecture today come in, because we're multiplying some powers of x together, so we know we add the exponents when we do that. So 3x squared times 4x cubed would be 12x to the fifth. 3x squared times negative 8x squared would be negative 24x to the fourth. 3x squared times 9x would be 27x cubed. And then 3x squared times negative 11 would be negative 33x squared. And we've multiplied the two polynomials together. All right, that's all we're talking about doing is using multiplication to actually combine two polynomials. We're not doing anything with factoring here at this point. Right, so the distributive property, pretty straightforward in a problem like that. Another possibility, so that was a monomial times something with several terms in it. Right, so we could write that out here, a monomial times a polynomial. The next situation is what happens if we take a binomial, something with two terms, and multiply it by a binomial, something with two terms. So let's say we have 3x plus 5y. I'm not going to do anything too terribly complicated here, times 2x squared minus 3. Right, that's a polynomial with two terms times a polynomial with two terms. For any of you who are watching live right now, do you remember a method you would use to multiply two binomials together like this? Anybody who's watching right now remember the name we use for this method? Yes, so I did get a text from somebody. Thank you, Gianna. That's exactly right. It's a FOIL method. Thank you for responding. And so the FOIL method, remember, refers to first, outside, inside, last. All it is the distributive property, but it's just an easy way to organize the distributive property. And it's first two terms together, 3x times 2x squared. And then the outside two, so that's first, that's where the f comes from. And then outside two, that's 3x times negative 3, that's our o. And then the inside two, so that'd be 5y times 2x squared, that's the I. And then finally 5y times negative 3, and that's the L. So that's our FOIL method. And that simply is a way of organizing the distributive property, is really all it is. So when you do all that multiplication there, you end up with 3x times 2x squared is 6x cubed. 3x times negative 3 is negative 9x. 5y times 2x squared is 10x squared y. And then 5y times negative 3 is negative 15y. Because there's multiple variables in here, there's really not any order that makes sense with the polynomial that I've written out at the end. So that to order for the terms is fine. Frequently, we try to write the polynomial in descending powers if we can, like in this problem right here, that was written in descending powers, right, where the biggest power was first, and then the next smaller power, and so on. But when you have multiple variables, a lot of times it's hard to write it that way. So like in this one, it would have been hard to write it that way. So this would have been fine just to leave it in this form. So that's a binomial times a binomial. Just use the FOIL method. Now, while we're talking about binomials, we mentioned this situation a few minutes ago. But what happens when you have not a binomial times a binomial necessarily, but a binomial that is squared? That's the case we want to look at here. So let's say we have 3x minus 4y, and that is squared right there. Now, remember, I told you about 20 minutes ago, something like that. One thing you're not allowed to do is use a rule of exponents here and square each of these terms separately. So this is not equal to, and please remember that, it's not equal to 9x squared plus 16y squared. You can't just square each of the terms separately. That's not allowed to do, right? Can't use a rule of exponents there. So what you could do here is you could just use what an exponent means and write this out as 3x minus 4y times 3x minus 4y, like that, and then use the FOIL method. So that would be one way to do this. So you get 9x squared. That's the first. And then the outside 2 would be negative 12xy. And then the inside 2 would be negative 12xy again, right? Notice you get the same thing in this case. And then the last 2 would be negative 4y times negative 4y would be plus 16y squared. And then notice there are some like terms. The middle 2 terms are like terms there, and you get 9x squared minus 24xy plus 16y squared. Now, what I want you to notice, and there is a pattern to this, and if you know the pattern, it's a good pattern to know, and it's going to make you a stronger college algebra student if you know this pattern for squaring a binomial. Notice that the first term, the 9x squared, is really, if you go to the beginning polynomial here, or the beginning multiplication problem, that's really just the square of the first term. That's really just 3x squared. And then the 16y squared is really the square of 4y. Like that. And then the middle term is minus. Then notice that the negative sign here and that negative sign coincide. And then notice that the 24xy, where that comes from, is really, that's just 3x times 4y, and then multiplied by 2, because there's 2 of them, and that will always be the case. The way we write that in symbols is we'll write it this way. For an addition problem, a plus b squared is a squared plus 2ab plus b squared, and a minus b, quantity squared, is a squared minus 2ab plus b squared. You don't absolutely have to know those 2 patterns, but it sure does make your life easier in college algebra as a college algebra student to know those patterns and to be able to write them out. It would be really nice for you to be able to do something like this. So just something simple, like if we have x plus 5 quantity squared, that you know that when you see a square like that, that's the square of the first term, twice the product of the 2 terms. So the middle term would be 5 times x times 2, or 10x. And then the last term is the square of the 5, which is 25. Really, remember, that's really just, if we write this out below, it's really just x quantity squared there and 5 quantity squared there. And then the middle term is 2 times x times 5. Right? It's just twice the 2 terms multiplied together. and that this sign of that middle term always matches this sign right here. This last term is always plus for either one of them. It would just be really nice for you to be able to do that and be able to write out this pattern without having to go through and use the FOIL method. So y minus 8 squared using that pattern would be y squared minus, and then the middle term would be twice the product of the two, so it'd be 16y plus, and then the square of the last term is 64, like that. All right, the last multiplication I want to look at is what happens if you have some kind of a multiplication problem where both of them have multiple terms and one of them's got even more than 2 terms. So like, for example, a binomial times a trinomial. And in this case, to multiply something like this out, you simply just use the distributive property. And this is the way I would think about this, is I'd multiply through by 2x here, and I'd multiply through by 3. This is all this is the distributive property. And it's kind of an extension of the FOIL method if you think about it that way. And then collect like terms at the end. So when you do this, 2x times 8x squared is 16x cubed. 2x times negative 3x is negative 6x squared. 2x times 9 is 18x. And then you multiply through by 3. 3 times 8x squared is 24x squared. A lot of times what students will do, and this is fine, is line these up and line up like terms in columns. So notice the 3 times 8x squared to give me 24x squared. Notice I put it underneath the other squared term. And then 3 times negative 3x is negative 9x. And then 3 times 9 is 27. And so I line up all the like terms. And then terms that aren't alike, those are off by themselves. And then just add the columns. So you get 16x cubed plus 18x squared plus 9x plus 27. And boom, we're done. All right, we've got it multiplied out. The degree, this is a polynomial with 4 terms at the end, and the degree of this polynomial is 3 because that's the biggest degree of any of the individual terms, like that. All right, so that's a really, really, really fast review of both exponent rules and operations with polynomials. I did it fast because this is something that I'm expecting that you have seen before, and maybe you just need a little bit of practice possibly, but that you are pretty familiar with this and you just need a little bit of practice. What I will be doing is I will be sending out a practice sheet. There's no web-assigned homework on this particular assignment. There's nothing that's going to be due, but I'm going to be sending out a practice sheet later today to everybody, probably through Remind. And I'll also be emailing. I'm going to be sending emails and Remind messages both for the first week or 2 of the semester, because I've got people out there that I need to get to and that are not on Remind yet. And so I need to make sure I get in touch with everybody. But I'm going to be sending out a practice sheet on basic, and it really will be basic exponent problems and also basic operations on polynomials. Probably 10 to 15 problems, and it will not be due for a grade, but it will be good practice going into factoring polynomials. So be looking for that later today. So I'll write that down here later today. Okay, so for those of you who are listening to me today, do you have any questions for me or any comments? I did talk fast today. I went through this material pretty fast. It'll gradually slow down as we start getting into topics slowly that I believe are things that you have not seen before. So, you'll notice that as we go through the semester. I'll be working more examples, be asking you for more questions to answer, things like that. Does anybody have any questions who's with me today live? Anything? All right, then I'm going to shut this down for the day. Thanks for attending. For those of you who are live, for those of you who are watching later, thanks for watching the video, the recorded video. And I hope you have a good semester with the rest of your classes and with my class both. Good luck. Do not get behind in my class as we go through the semester. Taylor, do you have any questions?
I do not. I'm just going to have to go over these notes again and kind of get familiar with it because it's been about 7 years since my last math class.
And that's Taylor. That's a good comment, and that's a common thing for a lot of people is that it's just been a while since they've seen some of these things, and that's one reason why So what you just said is going back over, and what I would recommend is going back over the lecture again and watching it. I also would use the practice sheet I gave you. I'm going to send you the practice sheet out later today. And I'll send the solutions to that practice sheet out probably later in the week so that you have something to look at.
Okay.
So you'll have enough practice here. So definitely one thing not to do for those of you who are with me live and those of you who are watching later, the recorded version, is to definitely not freak out or panic at the beginning of the semester. Sometimes I'll get students who will do that, especially Taylor, like it's been a while since you've been in a math class. It's easy to get overwhelmed at the beginning. But what you'll find is as you start practicing some of the basic problems, things start coming back to you. And I'm not going to say it's going to get easier necessarily, but I will say that your stress level will drop as you go through the semester. And so, because we'll be going through a lot of different things as we go along. But as long as you keep up with the material, you'll be okay. So and that's what my office hours are for also. I'll start having office hours today. I'll be online, I guess this morning from 11 to 12, but then again tonight, 8:30 to 9:30, where I just come to this WebEx room, just like I did for live lecture. I just open it up and you can attend. Anybody can attend from any of my classes, and I'm just there to answer questions, stuff that you're working on.
Okay.
So for all of you, don't ever hesitate to show up and ask me questions. And the sooner you start doing that, the better, definitely. So, all right, anything else from anybody? All right, then everybody have a great day. Stay warm. It's a nasty day today, that is for sure. And we'll be in touch, and I'll hopefully see you in the live lecture again on Thursday.
Okay, thank you.
Thank you.